Hello viewers, welcome back to the Multimagic channel. This is session 3 on video series basics. So as you know, we have been going through video series. The last couple of these sessions we have discussed a few basics about the video. So in this session, we will discuss about how to convert an image whose pixel format is RGB to another image whose pixel format is YUV. So uh, you know the significance of this pixel format conversions during compression and decompression. So that's the reason I want to bring this topic today. So before starting on the format conversions, let's quickly recap what happened in the last week. So as you know, we started with the decompression. So we have an MP4 file, and then with the help of FFmpeg APIs, AV read frame, we have converted that MP4 file into packets called AV packet. So this AV packet is a compressed data in the form of binary. I mean, this is not the raw data. This is like compressed data called AV packet. So all the packets are extracted from this MP4 file, and this packet we can write into the file called or in any binary format. So this is all the compressed AV packets that we are just writing it in the file. We have seen in the last video like how we will be or the sizes of these compressed packets are like 6 KB, 1 KB, and now at later we will be sending these packets to API called AV codec send packets. So here the compressed data is sent, and this AV receive frame will now receive the uncompressed packet called or the decompressed packet called AV frame. So now we are getting the AV frames here. I mean, from the MP4 file, finally we are able to get the frames. These are called the raw frames, and these raw frames are written into a file called RGB files. I mean, image files whose pixel format is RGB. So we have seen in the last video how these. So I will quickly show here. So we have this here, the raw frames. So all these raw frames we can see here. For example, if you open this file, this one particular raw frame. Yeah, I mean, this is, yeah, okay. I mean, we can view it in a different viewer. And these are all the compressed packets here, all the binary formats. For example, if you can go here, just give me a second. Yeah. So this is my project. Yeah, you can see here, these are the raw frames. From the compressed file, we got all the frames, and these are all the binary compressed packets or AV packets. So in such a way we can get all the packets written into a file, and we can get all the frames written into the file. But while writing all the frames into the file, we need a specific color format, and we have given the RGB color format. So this is what we have learned in the decompression part. And next, this is an interesting thing. So this is about the compression part. So this compression part we haven't discussed in more detail in the block wise. So I have just shown you how to compress a video in like where all other modules are coupled tightly coupled. So I don't want in that way to build this basics. So for that specific reason, I will be dividing this compressing part into building different building blocks. In today we'll be seeing this RGB to YUV format, and in the next video we will be seeing how to dump this YUV data into AV frames, and from there encode this particular frame using a X264 encoder, or in fact for any other encoder. So what we will do in the compression as overall from architecture point of view in the terms of FFmpeg, so we will be whatever RGB frames we have stored, so that we will be converting into YUV. So there is a special code. I will show you that how to convert the RGB to YUV, and these YUV data is now converted back into the AV frame data, and now these AV frames are sent to AV codec send frame, and this AV frame is compressed to AV packet. I mean, the raw data is now converted to the compressed called AV packet, and these AV packets, with the help of AV stream and with the help of AV write API, are written into the MP4 files. So this is the high level overview of how FFmpeg compresses a raw image into a MP4 file, a set of raw images into an MP4, written into an MP4 container. These are the APIs involved, and this is about the decompression. How FFmpeg APIs will extract the AV packets and from there extract the frames and write that frames into the RGB format. Okay. So this is about what we have discussed in the last week about compression and decompression and compression. So as I mentioned, now I will be discussing about this RGB to YUV conversion and why it is important. Okay. So before going into the conversion, so let's see what are the different pixel formats available. So as you know, like we have RGB pixel format. So this is one particular image which is extracted from our sample.mp4 file, and this has three different segments or three different colors. So this is a RGB color space, as the name suggests. This is R space, this is G space, this is blue space. So all these three combinations will give this particular image, and each pixel value is represented in 8 bits. Each bit for one for R, one for G, and one for B. That is total in 24 bits. A pixel format is represented, and each pixel value or each specific color space is of 8 bits, ranging from 0 to 255. So if R is some 128, will take 8 bits for G, 8 bits for B, 8 bits. A total 24 bits are used to represent an RGB frame. Okay. So next this will be an interesting slide on YUV formats actually. See, for YUV format we'll be not having any image in specific. So for YUV we'll be having a raw data which is in the format of YUV, which has all the header in the YUV and the data will be there. So Y stands for luma and UV stands for chroma. So it is also YUV is also called as YCBCR, where CB is called blue and CR is called red. And YUV, Y is for luma and UV is called chroma. So Y stands for brightness and UV stands for the color formats actually. So apart from the definition of the YUV formats, so there is also YUV downsampling. So for example, you can see the pixel formats as YUV 411p, YUV 420p. It means that, let's say we have 8 pixels. So let's say in our image, if we have 250, the image size is 8 by 8, we'll be having 64 pixels. So out of this 8 pixels, so Y stands for the brightness of the each pixel, and C stands for this U plane. This is called U plane, and this is called as V plane. And the color formats of the U and the color formats of the V is represented. Totally, it is like this here. So actually 4 is to 4 is the basic YUV format where all the color formats are restored. There is no colors used by the pixels here, I mean the previous pixels. So here if you can see in the YUV 422p, so each pixel value brightness is maintained same as this, but these two pixels are converted into one color space, and these two pixels uses one color space, and these two use one and these two use one. So U plane has 4 pixels and 2 pixels uses one color space and the remaining 2 pixels uses the other color space. So that is why it is called 422 chroma sampling. Okay. So now we have one more format called YUV 420. So it means 4 stands for brightness of all the pixels, So there is no brightness adjustment of it. So for each pixel has its own brightness like this. But here the U plane, these two pixels uses one color format, and these two pixels uses the other color formats. I mean, these two uses one and these two. And V plane doesn't uses any other color format. In fact, it just copies the U plane color formats. So the V plane will not have any specific color formats. It just reuses the U plane color formats. So in total, in YUV 420p format, we'll be having only two color formats, and the brightness levels for each pixel is maintained. But these kind of uh, color formats, I mean, like, not that much visible to our human eye. But in general, if you go to high, if you want to save your file in a high data format such that you want to show each and every color, especially in the movie making, we use this YUV 444 format where each and every color, each and every minute color is stored as it is. But the downside is like the file size will be more, but as mentioned, depends on the use case, we use these color formats. So this is about some detail about the YUV color format. So before going into how to convert YUV to RGB, so let's quickly check one quick thing here. So here I have a Python script actually, so which prints the RGB value. So here I'm having a 640 into 360 image. So let's see. So how the RGB value looks for an image. So this image is an RGB image, and as you can see, the image is each pixel value I'm printing here: R value, G value, B value. So this is how the RGB values are stored for each. So total 640 rows and 360 columns you'll be having because of the resolution of the image. So each point or each rectangular grid will show its pixel value ranging from 0 to 255. Okay, so it's printing all the values here. So yeah, I will be, yeah, so you can see here all the values are R value, G value, B value, and the RGB values are generated, images are generated like this, and these are the pixel values. So just from the understanding point of view, I just used here Python script. But since our course we are primarily focusing how to use FFmpeg, we will be showing how to convert an RGB to a UV format using FFmpeg APIs. This is just for understanding from the simplicity point of view. I have used Python script to understand how RG and V values are represented. So before diving into how to convert RGB to YUV, let's quickly run this program, extract, and I'm just printing not all the UV values. I'll be just printing one particular. So I'll go to this project, extract frames, build folder, and I will be running this extract frames, and I need to pass the sample files here. Okay, sample.mp4. So you can see here this video stream is detected, and the codec ID is this, and this pixel format is YUV, and this is the resolution. This is the bit rate of the video. So now we can see I'm just printing one specific frame. So total I have 1252 frames in this video. So I am just printing one specific frame here. So here this is frame 301, 10th row and 10th column. Y is 24, U value is 129, and V value is 130. Given the chroma subsampling information too. So before looking at how to convert an RGB image to a YUV image, let's see the significance why we are discussing this RGB to YUV. So as I mentioned in the earlier slide, so we have converting an AV frame into an RGB image. So here this is the how we convert an AV frame which we got from the FFmpeg APIs like AV receive frame. So we got this frame, and then now we are allocating an RGB frame. These are all the pixel formats, and then we are getting the context here. So this is the actual format. So this is YUV format, the actual format. And then this, because this video is an MP4 video whose container is X264 codec. So by default, the X264 codec will have YUV420p as a pixel format. Since we can't view the YUV format image, pixel format image easily, we don't have any ready-made image viewer like this or any other tools are there, but just for the simplicity point of view, before we want to save a frame into an image, the typical way we do is we convert this frame, which is by default whose pixel format is YUV420, to an RGB image. So this format is YUV420 of the input frame, and we want to convert this into a pixel, into a frame whose pixel format is RGB24. So we are telling that convert from this to use it with the help of the software get context. So this is one of the API provided in the FFmpeg. Okay. So now we need to just scale this. So first we are allocating the memory to the frame, RGB frame, and then we are uh, kind of initializing what context from which to which we need to, and finally we are using this software context here in SW scale, and then we are just simply scaling this image, original YUV image or YUV raw data into RGB image. Okay, so and then finally we are calling this function pgm save, which actually saves this data and then write it into a file. So this is about converting an AV frame whose color pixel color format is YUV to RGB. Okay, so why we are converting YUV RGB is to ensure we can view the images freely. Okay, so now this is during decompression. So now during compression, you can't directly use that RGB image because the kind of codec we are using is X264 codec. So all the X264 video codecs will use YUV420 color formats as I mentioned. So for that reason, we need to convert this RGB format back to YUV, which is the reverse process now. So as I mentioned in the slides here, like for decompression, one second. So for decompression, we convert these YUV to RGB, and for the compression, we convert these RGB to to YUV, and this YUV back to AV, and from AV frames we just simply apply the encoding process. Okay, so now let's quickly see how to convert this RGB to YUV. So it is similar to YUV to RGB. So you just need to define the dimensions of the image, and here I am loading this image, and then it is same like I am just first allocating the image memory for the frame. So instead of here that is frame, we are allocating memory to the frame in the RGB to YUV, but from in YUV to RGB, but from RGB to YUV, first we need to allocate memory for that image using these out planes. Out planes are this for Y plane, U plane, and V plane, and similarly we need to allocate this particular context from which to which we are converting from RGB to YUV this time. Okay, this output format is of YUV, and next simply we are just scaling this particular thing. So we are just passing this context here, and then we need to, these are pretty much important here, these planes and all these things we need to allocate the buffers properly, and once during the process of scaling these buffers get filled, and then we need to finally write those data into the image or into the files actually. So here it will be getting a raw data here again. So this is why we are dividing it by 4, as we discussed that U plane and V plane has 4 pixels. So that's the reason we are dividing it by 4, and then finally we are writing it into the file actually. So I have already compiled this code for simplicity, So if you go to this by particular folder, workspace, video basics, here you can see RGB to YUV. The build, this is the image, this is the input image, this image I have passed to my executable and I got this YUV. So now let's see if these two input and output images are same. So now for this we need to just, there is a tool called Pixel Viewer, so which is available as an open source in the GitHub, and we can load this image and then we can see, select the format YUV, and we can see, so now we can see the input and output are both the same. It means we have converted RGB to YUV successfully. So I'm just closing this tool. So that way you can convert your RGB to YUV format, YUV data, and now this YUV data we can directly dump this into AV frame, and then after dumping it to this into the AV frame we can directly encode this particular AV frame with the help of FFmpeg APIs, as I discussed earlier in the slides. So that way we will be going through the complete cycle from decompression to YUV to RGB, and then from RGB to YUV to AV frames, and then back to the actual encoded data using X264 as a video codec. So hope everyone has thoroughly enjoyed this video. If you have anything to say or if you have any queries, please do reach out to us. Thanks again for watching. Thank you. Have a good day. Bye bye.